welcome. So, my name is Ev. This is my YouTube channel about making stuff. I guess this is kind of a short introduction, but now we're going to get into the meat and potatoes of things. So, this YouTube series is going to serve as kind of a, here's my experience of building this thing, but also as a report for my homework for college. So, what is it that I'm building? I am going to be building a VTOL tailsitter. What's a VTOL tailsitter? Well, it is a flying wing like this that will sit on its tail, as the name implies. When it takes off, it will hover midair, and when it goes to move into forward flight, it will rotate itself and take off, create lift, and fly. Now, my aircraft will be a lot bigger than the one I just showed you, because that will have ArduPilot on board, which is a autopilot software for flight controllers and small UAVs. The materials I'm going to use to build this multi-rotor flying wing, this tailsitter, is going to be primarily foam board. I have 6 sheets of this cheap Walmart foam board that I'm going to use to construct the wings and the winglets and control surfaces. However, I'm going to build a center pod that should be 3D printed. I haven't quite decided on how that construction is going to work, but I'm going to modify either an FT Kraken from flight test or an FT Spear, also from flight test. Now that will depend on my testing with motors and things, which I'll cover in a future video. But suffice it to say, my goal for this project is to build a VTOL tailsitter that will fly autonomously and be able to fold up compactly so I can throw it in the back of my car and take it out to the field. So now, let's go over the electronics. Now, in order to control this flying wing, this tailsitter, I'm going to need a couple of things. First off, my handy-dandy Radiomaster Zorro transmitter. I apologize for the focus. Now my Zorro is going to be using this ELRS module that has an ESP32 backpack built into it. That's important. I'll get into that in a minute. Now what this is going to do, this transmitter will be plugged into this, or this will be plugged into the transmitter. And this is going to spit out a signal that will be picked up by this little itty-bitty ELRS receiver. And that receiver is going to connect up to this flight controller. Now I'm going to have to desolder a lot of these plugs and things, so the final build will be a lot cleaner. And if you notice, yes, this is another receiver. This isn't compatible with the software I want to use. So that's got to go, and the other one should give me better range anyway. But this flight controller will take my inputs from the radio, put it through the autopilot system, and use it to control the motors and servos. And the motors I'm going to be using are these 4 2212s from Sunny Sky, along with some ESCs that I got with them. Now, you might be wondering why I'm using 4 motors instead of 2, like most tailsitters. Well, the reason for that is I don't have budget for 2 large motors, so I figure using 4 smaller motors will probably give me enough lift to be able to pick up my flying wing vertically. Now, this is what's going to be the deciding factor in whether or not I modify a FT Kraken versus something like a Spear. Kraken's a lot bigger, and the Spear is a lot smaller and therefore lighter. So I'm going to be using those motors and these 2 plastic gear servos. They're not the best, but they'll do. Now, the question is, if I'm running an autopilot, that means I have to have a GPS. And the GPS I'm going to use is this Flight Test Easy ID remote ID module, because now that remote ID is a thing and this is going to be documented on the internet, I should probably comply. So therefore, this is my compliance. Now this remote ID module has UARTs, this little pin out here that I can solder onto and connect to my flight controller and use it as my primary GPS. Now, the way I'm going to get data transmitted back to me so I can tell where my aircraft is at and what it's doing currently in the mission I pre-program is using that receiver and that module. Now the way this works is this receiver, in addition to receiving data to transmit to the flight controller, it will also take data that it gets from the flight controller and transmit it back to the module. Now that module, upon receiving that data, will use the ESP32 chip on board, which is used for Bluetooth and Wi-Fi connectivity, and create its own Wi-Fi network, which I will then log into using a tablet or a laptop or something that uses Autopilot and Mission Planner, and use a Mavlink connection to get data from my aircraft. Now, with all the parts being laid out and my goals in mind, I'm going to tell you what those goals are. Number one, I'm going to build a functioning VTOL tailsitter. Now, why wouldn't I just build an autonomous flying wing or RC plane or something like that? Well, there's a couple of advantages that VTOLs have to regular fixed-wing aircraft. One of those being they don't need a runway to land or take off. You can give it a little landing pad that's, 2 by 2 feet or 4 by 4 feet, depending on how accurate your model is, and take off vertically and then cruise in fixed-wing mode. Now, cruising in fixed-wing mode means that it's using less battery than it would in a multi-rotor form, or than a multi-rotor would. Now, another thing that's kind of an advantage, for me at least, is I want to have experience building more VTOLs. Now, I don't know if you can see, but I have, that's the wrong side. There it is. I have my own RC planes that I built. This is one of the latest ones I've built. That's my P40 from flight test. But I've been building fixed wing for a while now, and I've been building some multi-rotor stuff. You can't see it, but behind me I have a Holybro X500 that's currently in parts. So, I want to get better at building VTOL, and I want to get better at showing people that I can build VTOLs, and I want to get better at telling people what I'm capable of, and advertising myself a little bit. So, here I am, practicing on social media, where no one will definitely see this. Now, another goal for the VTOL, now that I've gotten very off track, is that this should be an aircraft that is cheap to manufacture. Because, one, it should be repeatable. Two, I don't have a large budget. I don't have DoD money, sadly. But another requirement that I've given myself is I want it to be portable, which I've already talked about how I want it to be able to fit in the back of my car. But my eventual goal is to be able to have a small case for it to fit into. So we'll see if I can get that far. But another goal is that this should be something that's reliable and uses a fairly simple radio system. Now normally to get Mavlink data from a flight controller, you have to have a second telemetry radio rather than just one receiver on board the aircraft. Now I'm using ELRS, which has just had an update that makes it so it will transmit Mavlink data to the backpack that's on the transmitter module, and then create Wi-Fi network as I've described. So it's going to be cheap to manufacture, repeatable for other people to build, and portable and reliable. So, what I've been doing for the last couple weeks is gathering the parts that I've already showed you. And now, for the next couple weeks, I'm going to be building the airframe, which should be the next time that I post a video. So, with that in mind, happy trails, I suppose.